Okay, so let's look at how this helps us actually factor these polynomials. Okay, so example 2a asks us to write each polynomial in factored form. Okay, in factored form. Again, that's in a form where I'm about to multiply some stuff together to get the answer that you see in front of you, the answer given to you on your paper. Okay, so just as a way of a reminder, I'll go back up here for a moment. It's like I'm giving you this part and I'm asking you to find this part. Okay, so let's see how that happens. So 2a starts with 27 r squared s squared minus 18 r cubed s squared minus 36 rs cubed. Okay, so in order to write this into factored form, the first thing that we need to do is to identify the GCF, and we've already done some practice doing that, so that's helpful. Okay, so we're going to identify the GCF first, the thing that all of these terms are divisible by. So first I look at the coefficients, 27, 18, and 36. And like I mentioned before, all of those are divisible by 3 and 9. But the largest thing they're all divisible by is 9. So that's the one I want to choose. 9, good. R squared, R cubed, and R. The largest thing I can divide by is R. And then S squared, S squared, S cubed. So my largest factor there is S squared. Good, so how does that help me write this in factored form? Well, what you do is you take this GCF, 9rs squared, and you write it in front of a set of brackets. Okay, we call this factoring 9r squared out of our polynomial here. To do that, we divide each term by our GCF. So the first term is divided by 9rs squared, as is the second term, as is the third term. And then what I get after I divide each of those terms by the GCF goes inside here. Okay, those factored remains go inside this set of brackets that I've stuck the GCF in front of. Okay, so let's see what happens. 27 over 9, that's just 3. R squared over R leaves me with R. And S squared over S squared, those just cancel, so I don't have to worry about writing them. Okay, moving to the next term. Negative 18, don't forget the negative. Negative 18 over 9 is 2, so negative 2, more specifically. R cubed over R is just plain old R squared. And S squared over S squared, those just cancel again, so I don't have to worry about them. Lastly, I've got negative 36 over 9. That is negative 4. R over R, those cancel, so I don't have to worry about them. S cubed over S squared. That would be S to the 1, or just S. And then I end my brackets. So, just to be clear, this is my answer. Okay, this is the factored form of what I started with. Okay, the way I know I'm right is when I multiply out this factored form and I end up with where I started. Okay, so that's a way of checking. You'll see in your notes it says check with multiplication. That's what we're going to do. We're going to check to make sure that this is indeed the thing that you multiply together, or the things that you multiply together to get this multiplied form. So just doing distributive property here, we're going to multiply that 9rs squared into each of those terms. giving us 27, and then r times r is r squared, and then s squared by himself, minus 9 times 2 is 18, r times r squared is r cubed, and then s squared, and then minus 9 times 4 is 36, and r times, there's no r there, so just r, s squared times s is s cubed. And let's make sure that I have everything I started with. I've got 27 r squared s squared down there, and the same thing up there. These match as well, as do these. So I know for sure that I'm right. I have worked backwards. Hooray! Okay, don't need to check the back of the book. Well, it's a good idea to check anyways, but you see the idea, right? Let's do another example here. Okay, we're going to do 2b. 2b. We've got 4 np squared plus 10 n to the 4th p minus 12 n cubed p. Good. And again, we want to write this in factored form. Okay, it's a form that when I multiply it together, I will end up back here. Okay, so just like I did last time, I'm going to identify the GCF, greatest common factor. Okay, and let's see here. I've got a 4, a 10, and a 12. So the largest thing I can pull out is a 2. Then I've got n to the 4th, n cubed. The largest thing I can pull out is just n. And then I have p squared, p, and p. So the largest thing I can pull is a p. So 2np is my GCF. And like I did last time, I put that GCF in front of a set of brackets. Okay, and I factor out 2np out of all those terms, or I divide them all by 2np. And write the remaining stuff inside these brackets here. Okay, so 4 over 2, that's just 2. N over n, those cancel. P squared over p is just p. And then 10 over 2, well, that's 5. And then n to the 4th over n, that's n cubed. And then the p's here, p over p, those just cancel. And then lastly, negative 12 over 2, don't forget the negative. Negative 12 over 2 gives me negative 6. N cubed over n gives me n squared. And p over p, those cancel as well, so I don't have to worry about them. And there we go. Again, this is my answer. This is the factored form of what I started with. To make sure I'm right, I'm going to multiply them out and make sure I get what I started with. Okay, so let's multiply this out using distributive property. So 2np times 2p is 4np squared. And then 2np times 5n cubed. 2 times 5 is 10. N times n cubed is n to the 4th. And then the p just tags on at the end. And then 2np times negative 6n squared is negative 12. N times n squared is n cubed. And the p is by himself. Okay, good. So you'll notice that this piece down here matches this guy. This one matches this one. And this one matches this one. So I know for sure that this is correct. But again, this is my answer. That's what the book will be looking for. Okay?